So in your notebooks, hopefully you've got this right now in your notebooks. As we start talking here, we're going to isolate some common things about our heart rate. Let's start with what your heart rate is. What is your heart rate? It's measured in beats per minute, right? What happens if your heart rate hits zero? You're dead. So if we're measuring somebody's workout, is their heart rate going to start at zero? Probably not. Is it going to end at zero? Fingers crossed, hopefully not. Okay? Unless you're Travis trying to deadlift and you throw out your back. Jeez, kid. Come on. Form is everything. All right. So Franco's heart rate increases steadily as he does some warm up exercises. So we said we don't start at zero, but are we going to start all the way up? No. So maybe in your notebook, try and say that you started. Maybe we start right here at the E. And what would your heart rate do if if he's doing some warm-ups? What would happen to your heart rate if you're warming up? Go ahead, Antonio. It'll start slowly going up. Good. So on your graph, draw it slowly going up. After he's done warming up, he maintains a steady heart rate for several minutes as he runs. Once he's done running, his heart rate starts to go back down and goes back down to normal with his cool down walk. Is this a continuous or a discrete function? So go ahead and sketch your graphs and let's see if they match mine or are close to it. So I'm warming up. I'm going to increase my heart rate to warm up. I'm going to stay consistent, and then I'll slowly start coming back down. Now, it goes back down to the point that I started. Hopefully, when I'm finished, my heart rate begins again. Maybe a little bit higher because I couldn't tell on my end. Is this a discrete or continuous graph? Is it something that happens all the time? Is your heart rate always going? Yeah, probably a good thing it is, right? So this isn't just measured in, oh, my heart is beating 80 times a minute, and then all of a sudden it's beating 130 times a minute. Okay, so this would be a continuous function. The last one that I want you to try in your notebook looks like this. Please take a second and draw this graph into your notebooks. Maybe we'll start by answering this last question on this one. Is this a discrete or continuous function? Talking about movie rentals. What do you think? Good, it'd be discrete. Can we have like half a rental? No. So we're not going to have all these numbers in between. So this will be a discrete function. So discrete functions are dot to dot. So Laura has $15 to spend on movie rentals. Each rental costs $3. Sketch a graph to show how much money she might spend on movies in a week. Tell whether the graph is discrete or continuous. Cool. So the cost versus the number of rental movies. If I rent one movie, how much does it cost? $3. If I have two movies, how much does it cost? $6. And three movies? $9. Do we get the idea here? 4 movies would be 12, and 5 movies would be 15. One of the temptations here might be to draw it going down, saying, well, she's only got $15 for each movie she rents. She has less money. Okay, but this is the cost of the movie rentals, not how much money she has. So we need to pay attention to our labels on our axes. Any questions on these two? So we're graphing, or we're recognizing relations and functions 3 different ways. We start with these 4 points, and we notice our x values are first, so they'll go right down here, -2, -1, 3, and then -1 again. And then we can add in our y values, 5, 1, 1, and 2. And then let's look at a graph of these to see if we can determine if it is a function looking at a graph. Again, my x goes left to right, my y goes up and down. Doesn't look like I need anything bigger than 5, so here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Well, now we'll just graph the points here. Maybe I'll graph them in blue so we get a nice picture. -2 up 5. -1, 1. 3, 1. And -1, 2. That's what this would look like graphing. Let's do the mapping before we start answering questions. Mapping says I start with my x values, which are -2, -1, and 3. And I'll move to these y values of 5, 1, and 2. -2 goes to which value? It's connected to where? It goes to the 5. The -1 goes where? It goes to 1. Anything else? And it also goes to 2. And then the 3 goes to the 1. So we're going to answer a couple questions here. Is it discrete or continuous? Is it a function? What is the domain and range? So let's start with discrete or continuous. Looking at this graph, is it discrete or continuous? Is everything connected? No, so it must not be continuous. So this would be discrete. Let's answer the question, is it a function? How do I determine if something is a function? Good. For each x value, it only appears once. So I can look at a table to determine if it's a function. Well, if it's a function, this -1 can't appear twice. So we know it's not a function. Since the x value -1 has 2 y values. And how do we, oh, so you can barely see that. Barely see that. Well, how do we determine if it's a function by graph? We use the vertical line test. And apparently my lines are not very vertical. But when I do this third one, what do we see about it? It hits 2, so it can't be a function. And when we look at the mapping, what do we notice about -1? It's used twice. It's got 2 arrows going 2 different places. Okay. What is our domain? Domain means what? Your x values. What are our x values? -2, -1, and 3. Since there's no numbers in between them, I don't want to use an inequality. This is a discrete domain, so it only includes -2, -1, and 3. We use these fancy little brackets here as a set. So this is a set. This is all the numbers in that domain. What about the range? Five, 1, and 2. And I'll list them in order. 1, 2, and 5. And we know that because these are our domain values. And these would be our range. Likewise, on a graph, these would be our domain values. And this would be our range. And then similarly, in this mapping, domain versus the range in the other one. Okay. Can you ask any questions about how to determine a function from a table, a graph, or a mapping? Good. Yep. If the x value has 2 y's, it's not a function. Any questions on domain or range? Good deal. I think we're done for the day.